Hey guys, let's discuss round 5 from Apple interview loop series, which is low level design round. And here you have to design Apple wallet. Okay, so this is a strong low level design payment system question because it tests both object oriented design and candidate's ability to reason about security, okay, reliability, offline behavior, transaction, and extensibility. So see, here we will be discussing answer based on three roles, which is software engineer, senior software engineer, and architect. Okay, so expectation differ by level. What software engineer is supposed to answer, he will be saying that he would be expected to design core wallet functionality such as adding, removing cards. Okay, you can add or remove your credit card, debit card, and then transactions and APIs also it should handle. Senior software engineer, what he will be saying, design tokenization, offline payment, secure transaction processing, retries, notification, extensible object oriented components. Okay, so tokenization means we will not use the direct credential or your not the credential your card detail or this kind of personal information. Instead of that, we will be using tokenization. Okay, then architect, so he's supposed to say expected to design a globally distributed payment orchestration platform. Okay, so globally means in multiple countries, let's say we have deployed the application, and a platform supporting fraud detection, multiple countries, then compliance, high availability, and disaster recovery and event driven architecture. Okay, so now what software engineer will answer, I would model the wallets as a collection of payment instruments. Okay, you have different payment instruments, credit card, debit card, different cards, different bank account. So it is the collection of payment instrument. Each card would have its own life cycle and payment behavior. The wallet service would expose APIs for adding or removing cards and initiating transactions. Okay, so now senior software engineer, what he will be saying, I would design Apple Wallet to manage cards, tokenized payment credentials, and transactions. Okay, so instead of storing the actual card number, I would use tokenization for security. That is what I was saying. And a payment service would handle the transaction and communicate with the payment processor. Each transaction would follow a clear state, such as so you will have a state of the transaction, like transaction is created first, then processing, authorized, captured, and then completed or failed. Okay, so randomly you cannot assign any stage. It would be follow the step by step process. Now I would use idempotency keys to prevent duplicate payment when requests are retried. Okay, when you are retrying request, so idempotency key should be there so that it will not transaction will not process twice or multiple times. For network failure, we would use safe retries and transaction status checks. Then offline payment can use secure credentials stored in the device's secure element. I would also keep tokenization, payment processing, fraud checks, notification as a separate component to the system is secure and easy to extend. So this is all things senior software engineer will say. Okay, now what is architect expected to say? So he will say that at the architect level, I would design Apple Wallet as a globally distributed payment platform. Okay, globally distributed. So in multiple countries, multiple region, we have deployed the application. The wallet service would manage cards, devices, while separate services handle tokenization, payment orchestration, fraud detection, and payment routing. The payment orchestrator can choose different processor based on the country, network availability, and latency. Okay, so you will have a payment orchestrator here. He will be talking about payment orchestrator. And I would use event-driven architecture for notification, audit, and analytics with idempotent processing to handle the duplicate events. The system should support multi-region availability, disaster recovery, and strong transaction consistency and secure token management. Okay, I would also design reconciliation. Reconciliation means comparing two sets of data, make sure they match. Okay, so I would also design reconciliation to compare our transaction with processor bank records and handle mismatch, security, compliance monitoring, and auditability. Okay, then auditability would be built into the architecture from the beginning. So all these things he would be answering. Okay, I'll remove this so that you can read it. Okay, now core entities, if you talk about, so see, wallet should have first the user information, right? And then you have to add multiple cards, let's say credit card, debit card, or transit card. So you should have the payment instruments. These all comes under the payment instrumentation part, and then your transaction. Okay, so 3 entities. Now basic classes, how many classes you will be having? So you will be having one wallet class, then payment instrument class, then transaction class. Okay, so here in wallet class you will have the wallet ID, user ID, payment instruments, and then transactions. Okay, so all the IDs. So this wallet class will have that. And then in payment instrument, so your payment your instrument ID, okay, your type, status, and token. And in transaction you will have the transaction ID, instrument ID. Okay, instrument ID means transaction you are doing with from which card, credit card, amount, currency, status, and timestamp. Now core API, if you talk about, so you will have the wallet and card post request. Okay, so you will be adding the cards there. Then you can delete the card, okay, by its a card ID. You can get the card information, okay, and then you can get the transaction informations also. After that you will get the you can post the transaction. Okay, you can save the transactions, and then you can get the particular transaction ID detail. Okay, so the basic flow will be like this. Apple Wallet, okay, so it will call the wallet service, and then in your wallet service you can have multiple methods like addition of the card, removal of the card, then payment. Okay, and then transaction service will get called, and from there payment network. Okay, so it will go to payment network. Okay, now let's talk about few follow-up questions here. The first question is, how would you design the card hierarchy? Okay, how would you design the card hierarchy? So software engineer will say that use an abstraction for different payment instruments. See, let's say you have a payment instrument. So I was talking about this. You will have a credit card, debit card, and then transit card, let's say different cards. So the base class contains common attributes and operations. Now senior software engineer, what he will be saying, use interfaces where behavior differs. Okay, so like for example you can have the payment instrument interface, and then there you can have the tokenize, authorize, and detective methods. Okay, different methods. And then you can have the payment processor interface, and you can have the authorize, capture, and refund method there. Okay, so the class who will implement this interfaces will give its own implementation of these methods. So this keep the design extensible when new payment methods are introduced. Okay, so architect, what he will be saying, avoid creating a large inheritance hierarchy for every payment type. Okay, so he will prefer interfaces, composition, then strategy pattern, factory pattern, and dependency injection. So interfaces means define a contract that classes must follow. Okay, then composition, build a class using other classes instead of inheriting from them. Okay, then strategy pattern, so encapsulate different algorithms or behaviors and choose one at a time. Okay, then factory pattern, so create object without exposing the object creation logic to the caller. Now next is dependency injection, so provide a class with its dependencies from outside instead of creating them itself. Now this allows the new payment method to be introduced without modifying the core wallet logic. Okay, now follow-up question 2 is, how would you implement tokenization here? So software engineer will say that instead of storing the actual card number throughout the application, use the secure token representing the payment instrument. Okay, so the wallet uses the token instead of exposing the actual card number. So what senior software engineer will say, separate card credential, then payment token, and token metadata. This token should be unique, then non-sensitive from application's perspective, and revocable. After that, associated with a specific payment instrument, and protected by strong access controls. Okay, now use hardware backed security where appropriate. So simple example, like imagine a user adds Visa card to payment app. Okay, so let's say the card number was this and CVV number was this, so stored securely in a payment vault, let's say. So now payment token, something like this. Okay, it will generate token something like this. This one will be random, unique, and revocable token. Now app uses this token instead of the card number. Okay, so token metadata, so card type will be Visa, last 4 digit, let's say this, and so this expiry date is this, so this kind of metadata you will store. Okay, token metadata, status is active, so the application seek this token number while the actual card credential remains protected in the secure vault. Okay, so two things there. Now architect, what he will say again the same thing, design tokenization as a dedicated security boundary. Okay, so wallet will call token service will have information stored in token wallet, and then key management. Okay, and from there it will go to payment network. The core wallet service should have no need to handle raw payment credential. Okay, now follow-up question 3 is, how would you handle transaction? So software engineer will say a transaction can move through different states. Okay, so we already talked about this, like from created to authorized, then from there to captured, and then completed. And then failure states would include failed, cancelled, and refunded transactions. Now senior software engineer, he will be saying use a state machine rather than allowing arbitrary state transactions, like from created to processing, then processing to authorized or failed. Okay, then from there captured, and then completed. So each transition should be validated. For example, a completed transition should not transition directly back to created. Okay, now what architect will say, persist transaction state and treat payment operations as idempotent state transitions. So each transaction should have transaction ID, idempotency key, then current state, previous state. Okay, and then payment token, amount, currency, country, timestamp, and the processor response. Now follow-up question 4 is, how would you design notification? Okay, so software engineer will say after a transaction changes the state, send a notification. Senior software engineer will say use an event-driven design. Okay, so event-driven design means, let's say transaction service call completed the transaction, and then event bus, through event bus it will notify different services like notification service, fraud service, analytics, or audit service. So now this prevents the transaction service from directly depending on every downstream consumer. Okay, now what architect will say, he will say that use durable events and asynchronous processing. Okay, so event might include your payment authorized, payment captured, payment failed, payment refunded. Okay, card edit, card remover, fraud detected. So consumer can independently process these events. Follow-up question 5 is, which design pattern would you use? So software engineer will say that he will use factory, strategy, and observer. Okay, blindly just say observer. Okay, for the notification, strategy for your business logic, and then factory if you wanted to create multiple objects of different type. Belongs to the same factory pattern. So now senior software engineer, what he will be saying is strategy pattern, he will use different payment processors, let's say. Okay, so there he will be using the strategy pattern. Now factory patterns will create payment instruments, like payment instrument factory, credit card, debit card. So there he will be using factory pattern. Observer pattern, so notify multiple components when transaction state changes. Okay, for the notification basically. State pattern, so manage transaction lifecycle. Okay, from different state, created, processing, all these things. Now what architect will say, so he will say use pattern only when they solve the real extensibility problem. Okay, not because this is the architect round, so you have to use introduce different design patterns. Okay, that should not happen. Potential design will be like this. So factory pattern you will be using for the payment instrument. Okay, strategy pattern you will be using for payment processor. State pattern you will be using transaction lifecycle, and observer pattern or event bus you will be using for notification, fraud, or audit purpose, and then chain of responsibility, so payment validation. The goal is not to demonstrate as many design pattern as possible. Okay, so the goal is to create a system where new payment method or processor can be added without changing core business logic. Architect level architecture will be something like this. So user device will call your Apple wallet. Okay, and from there it will go, request will go to API gateway, authentication will happen there. Okay, authentication, authorization, then payment orchestrator would be there, which will be responsible for your fraud engine service, then policy engine, routing engine. Okay, so it will route the request, and let's say policy engine, so you will have a multiple processor. Multiple processor will work according to their capability, and then the payment will go to payment network then. So now supporting infrastructure, if we talk about here, so we are supporting here tokenization, we are supporting here key management. Okay, then secure devices storage, configuration service, compliance engine, monitoring, alerting, then multi-region replication and disaster recovery. So that's it. Thank you.